Good morning, sir. This is Samvatsar HL,
And this is Bharat MR. So we are doing our
and we are doing
FEA
FEA EL of vibrational on camshafts. Firstly, I would like to talk about what are camshafts. A camshaft is a key component in an internal that requires the timing and movement of the engine's intake and exhaust valves. It consists of a shaft with one or more cam lobes which push against the valve train to open and close the valve at precise intervals during the engine cycle. This ensures that the engine's air fuel mixture is properly managed and exhaust gases are efficiently expelled, contributing to the optimal engine performance, fuel efficiency, and emission control. The functions that are done by a camshaft include the valve timing operation, regulating the air fuel mixture, it manages the exhaust gases, optimizes the engine performance, affects the engine efficiency by contributing to better fuel efficiency, it improves the emission control. It supports variable valve timing systems in advanced engines and adjusts to providing different valve timings for various driving conditions. There are different types of camshafts. There are several types which include the overhead camshaft, which is the OHC, which includes a single overhead camshaft, a double overhead camshaft. Similarly, we have a push rod camshaft, which has an in-block camshaft which is located within the engine block. This camshaft operates through a push rod and rocker arm mechanism. We have a in-head camshaft, and then we have a variable valve timing camshaft. We have rotary camshafts as well. Each type of these camshafts have its own applications and advantages depending on the engine design and performance requirement. Here is a basic camshaft that is used in an engine. Further design and further the design part will be talked by Bharat MR.
so we have to open SolidWorks and select part. Select the front plane for sketching. Select circle. Click on smart dimensions. 15.2 mm, and the bigger circle is 32.5 mm. Now select line.
Correct. Wait.
Select the smaller circle. Hold Control key. Select the line. Give tangent. Again, same thing for the bigger circle. Tangent. Select line. Click on mirror entities. Mirror this. Mirror about. Entities to mirror only this line. Mirror about the center line. Click on mirror. Now select trim entities. Trim all the unwanted parts. There's extension in the line which has to be trimmed on both the sides. Now click on features, extrude boss base, select mid plane, give 8.1 mm. So now click on the eye symbol here, select view temporary axis, select linear pattern, bodies, select all bodies, select the temporary axis that we have chosen here, change the direction, this should be 65 mm, Click OK. As we can see now, there are two paths formed. Now go to the command bar, search move face option. Now select on parameters, select this 180 degrees, rotate this particular object by 180 degrees. We can see now that this part is rotated by 180 degrees. Now click on the other face, that is this face, press the space bar, select normal to. Now click on sketch, select circle, draw a circle, smart dimensions. The diameter of the circle should be 21 mm. Now again click on extruded boss base. Now here select blind 140 mm in direction 1. Select direction 2. Again blind. Give 30 mm in the other direction. Now we can see this part is created. Now again we have to use linear pattern to create other three bodies. Again click on linear pattern, give three bodies, give 150 mm, bodies, select all bodies, select the axis, temporary axis that we have chosen here, select the bodies and this axis, select the bodies, come here, come to direction, select this axis. Now we can see three particular bodies. Click OK. Now our camshaft is ready. Save this, Control S, save this as IGES file. We'll save this as camshaft, save all bodies. Now our camshaft is saved. Now we have to open Ansys Workbench. Here I've double clicked on model. This tab appears here. Now right click on geometry, import geometry, browse. Select this, open. Now again right click on geometry, edit geometry in space claim. It takes a bit of time to open. As we can see here, there are three parts in this. So what we have to do here is we can see an option called combine. Click on this. Click on this and select all the bodies. Now combine. Now open Ansys Workbench. In Ansys Workbench, double click on model, uh, right click on geometry, import geometry, select on camshaft 1. Now open the model in, right click on geometry, open the model in space claim. Now as we can see, there are three parts, 1, 2 and 3. We have to combine all these three parts into one part to make it a single camshaft. So select all the bodies, go to design and click on combine. Now we can see here it is a single body parts, single part. So now we can see that it has merged and it combined into a single part. So now we have to close space claim and again open workbench. Now we have to open model, double click on model. Now my friend Samvatsar will explain.
So as we can see, we have the camshaft model right here. And now the main part, now we'll have to select the material of which we'll be using the camshaft of. So here we can see that we have a, well, let us press the plus mark on the materials. And we can see structural steel has been selected as the material to be used for the camshaft analysis. So once we're done with this, now let us go to put on the constraints that we'll be applying on the camshaft. So before that, let us go to mesh, right click on mesh and generate mesh. Once the mesh is generated like this, now let us put our constraints. Let us go to model and right click, insert and put remote displacement. We know that a camshaft is usually fixed but is allowed to rotate in a certain axis, which is the axis of rotation along the central of the camshaft, and it doesn't go under any kind of translational motion. So, considering all these factors, as we can see from the bottom right side of the screen, we can see that the three different distinct axes, the x, y, and z. We can see that the axis of rotation of the camshaft is in the z axis. So therefore, the translational components all will be zero, and the rotational on x and y will be zero, keeping the rotational on z as free. So we'll make this zero, we'll make this zero, we'll make the z component as well as zero, the rotational x 0, rotational y 0, keeping rotational z free. Now let us select the phase on which we want to put the remote displacement. Let us select this one here and apply. Let us do this. Let us repeat the same process again. Go to model, right click, insert, remote displacement. Because of the same factors, we'll apply all these as 0 and keep rotational z as free. Now let us apply this on the other end of the camshaft. and select and apply. So the only constraints that we'll be applying on this camshaft analysis are the remote displacements without any kind of force acting on it, so that we can get to know the frequencies at which the different modes of the camshaft will be undergoing. Now let us change the number of modes. Let us press analysis settings and change the number of modes as 10 from 6. Now we will be getting the frequencies and the mode numbers for 10 different values. Now let us go to solution, right click on solution, insert, in deformation, select total deformation. Now let us solve. Now here on the right hand, or on the bottom right, we can see a table which says mode and frequencies. This is the different kind of frequencies that is found at the different modes of the camshaft. And we can clearly see that the frequencies go on increasing as the modes increase. This increases the efficiency of which we can be able to find the precision of the frequencies that is acting using these finite element analysis methods provided by Ansys. Now let us try to find the deformations, total deformations due to these modes at different modes and the frequencies at these modes. Let us select all the modes and frequencies, right click and export mode shape, create mode shape. As we can see here, we can see all the different mode. Here we will evaluate all the results first, and then we can see that all the deformations are given mentioned below here with the changes in the shapes of the camshaft due to these modes, due to the constraint put on them and the frequency that act on them. We can see that as we go down the deformation values, more is the deformation that is caused, and due to that higher the frequencies. So we can understand that more frequency is directly proportional to the more deformations that is caused, which can also be thought as, which can easily be understood by taking resonance into contact. When we consider resonance is when the natural frequency is equal to the actual frequency of the body. So here, when the resonance frequency is met, we can see that the camshaft's shape is changing vividly and extremely, and this may cause catastrophic failure in cars or in any kind of devices and machineries that it is used in. So therefore, the camshaft must be designed in such a way that resonance is not met when it is being run. So, using ANSYS and using such softwares and FEM methods, we are able to understand the vibrational analysis and the deformational analysis of such components and find out their frequencies and deformations that is caused due to the constraints that it will be found in when they are put into machineries. The reasons for these vibrations in camshaft can be due to imbalance in the camshaft, the harmonic vibrations, which is the main part, the timing belt or chain issues. We even have the valve train issues, bearing problems, engine load variations, incorrect installations, crankshaft camshaft relations, operational factors, and external forces because of the mounting or engine misfiring. These are all the reasons that may cause vibrations in camshafts. But the main reason is the harmonic vibrations, where camshafts can experience harmonic vibrations when the frequency of the engine operation matches the natural frequency of the camshaft. The resonance can cause significant vibrations. So the design and material of the camshaft can is the major influence in the natural frequency. So if the design doesn't adequately account for operational frequencies, harmonic vibrations may occur and may cause a catastrophic failure. So this is our experiential learning for understanding to realize how important using such methods of finite element analysis and methods provided by Ansys Workbench to understand and design components that are used in real life and used in our daily life by people.
And there's one more thing. We usually use two materials to design a camshaft, that is billet steel and cast iron. So we have shown here for steel, material steel. So by considering different frequencies, we can take which whether steel is better or cast iron is better. Steel is used for strength and durability, whereas cast iron is used for low to moderate performances. Thank you.
Yes, thank you. This was our elemental finite element analysis experiential learning, and where we've discussed about the vibrations that is caused on a camshaft due to the constraints on it, and our learnings that will be mentioned as we understand the frequencies and how resonance and how these elemental analysis, finite element analysis methods are helpful for understanding and designing purposes for everyday use components. Thank you.